Okay, now we're going to look at some application problems, some word problems using quadratic functions. So this first one, we've got a backyard farmer. I think there's more backyard farmers in quadratic equation word problems than there are in real life. But he wants to enclose a rectangular space for a new garden within her fenced backyard. She's purchased 80 feet of wire fencing to enclose 3 sides, and she will use a section of the backyard fence as the 4th side. Find a formula for the area enclosed by the fence if the sides of fencing perpendicular to the existing fence have length L, and what dimensions should she make her garden to maximize the enclosed area? All right, so she has a fenced backyard. So let's sketch this out. It's always a good place to start. She's got a fenced backyard, and she wants to make a little area in here with her new fencing. And they say that the sides of the fencing perpendicular to the existing fence have length L. Okay. So how could we label these other things? So this fencing already exists, right? So they want us to find a formula for the area enclosed by the fence. So the area is going to be this times that. So let's write down what we know. Well, we know if this side is L, that side is L. And then how could we represent this? Well, we know we have 80 feet of fence, right? So maybe this will be 80 minus 2L. So what's our area function? Our area as a function of L, of this garden area, is going to be L times 80 minus 2L, right? This side times that side is going to be the area. And we could multiply this out. We'll get minus 2L squared plus 80L. And sure enough, that looks like a quadratic. So what dimension should she make her garden to maximize the enclosed area? Well, let's just think about this for a minute. Without being very careful about it, what is this going to look like? It's a parabola that's opening down, right? So it's going to look like that, right? And the maximum area is going to happen there at the vertex. So really they're asking us, where is the vertex of this equation? Luckily, we know how to find that. The vertex, the x value of the vertex, so we could call that h, right, happens at minus b. So in that case, this is a, this is b, and we don't have a c, minus b over 2a. So minus 80 over minus 4, so that's going to be 20. Does that make sense? If this was 20 feet, yeah, that seems to make sense. Then this would be 20 feet, and this would be 40 feet. So her garden would be 20 feet by 40 feet, would be the maximum area, right? If she made it a little bit wider, her area would go down. If she made it a little bit narrower, her area would go down. Right? That's the perfect dimensions for maximizing the area. Okay, so really they were just asking us to set up a quadratic and then find where the vertex is. Most word problems with quadratics are asking you to do that, but not all. All right, let's do another example. And we can see down here they have a graph for us. Right, the equation looks like that. And there's our parabola. And we could even find the area, the actual area of the garden would be 800 square feet. All right, let's talk about money. The unit price of an item affects its supply and demand. That is, if the unit price goes up, the demand will usually decrease. For example, a local newspaper currently has 84,000 subscribers at a quarterly charge of $30. Market research has suggested that if the owners raised the price to 32, they would lose 5,000 subscribers. Assuming that subscriptions are linearly related to the price, what price should the newspaper charge for a quarterly subscription to maximize their revenue? All right, so there's a lot going on here. So they say there's something linear. What do they say is linear? Subscriptions are linearly related to price. Okay, so let's call the subscriptions Q because that's what your book does. I would have probably chosen S, but let's just go with Q. So we have the number of subscribers, the quantity, and we have the price, and those are linearly related. So let's see, they give us some data points, right? They tell us, so subscribers is going to be a function of price. That's what they tell us. So I probably wrote these in the wrong order. Let's write Q over here. They tell us if the price is $30, they have 84,000 subscribers. And if the price was $32, they would lose 5,000, so they'd have 79,000 subscribers, right? So maybe we should write an equation, a linear equation that would describe describe this relationship. So first we'll have to find the slope, right? So slope is going to be change in y over change in x. So 5,000 over $2, so 25. For every dollar they raise the price, they're going to lose. Did I do this right? Nope. See, look. This should be 30 and that should be 32 because we want this to be negative, right? For every dollar that they raise the price, they're going to lose 2,500 subscribers. Oh, let's move this over. All right, so always check your work and see if it is making sense because sometimes you'll make a mistake and then you can catch it early on instead of late on in the problem. All right, so our slope is this. Let's use the point slope form. So y minus 84,000 equals minus 2,500 times x minus 30, right? And I use the wrong variables. Y, we really mean q, and x, we really mean p, right? All right, so we could solve this to put it in the form minus 2,500p plus, what's 30 times 2,500? 75,000, right? Plus 84,000, right? If we bring that over. So we could say Q is minus 2,500p. What's 75 plus 84? 159. Okay, plus 159,000. Okay, so let's just interpret that real quick to practice. If the price was 0, the y-intercept would be 159,000, meaning there'd be 159,000 subscribers if they just gave it away for free. All right, I could kind of believe that. All right, so now we know we have the number of subscribers as a function of price. And what do they really want us to figure out here? They want to know the price they should charge to maximize their revenue. Okay, revenue is something we haven't even talked about yet, right? What is your revenue? Well, your revenue is going to be your price times the number of things you sell, right? If you sell something for $2 and you sell 10 of them, you'll have a revenue of $20. So let's see, what would the revenue function be here? It's going to be P times this function, minus 2,500P plus 159,000P, or just 159,000. So can we make this a quadratic? Yep, if we multiply it out, sure enough, we get a quadratic equation. And they're asking us to maximize the revenue. Does that make sense? Well, we've got a quadratic, the leading coefficient is negative, so yep, it's going to go down, and we want to find the vertex, right? That's where the revenue is going to be maximized. So let's find the vertex of this thing. The h value is going to be minus b over 2a. So 159,000 divided, or minus 159,000 divided by negative 5,000. And I'm going to cheat. That's at 31.8. Okay, if you put that in your calculator, I wrote it down earlier. $31.80. Does that make sense? Yeah, that's definitely like in the range of what we'd expect, right? They're looking around $30 for this subscription. I mean, obviously, if we got some number like 700, probably doing something wrong, right? So that makes sense. Yeah. And could we find what the maximum revenue is? They don't really ask that, but how could we figure that out? Well, if the price is $31.80, the maximum revenue is going to be the Y value, right? And I think they even give us a graph. So let's just cheat and look at that instead of putting this in our calculator. Yep, here's our graph, right? If our revenue is $31, or if our price is $31.80, our revenue is in thousands of dollars, 2,528.1. So that'd be like 2 million, right? $528,100. That would be the revenue. Okay. Did you guys know you could solve problems like that? You guys are going to be rich. You can figure out all these fancy math things. All right, let's do one last problem. If I can find it. All right. We're going to throw a ball. This is another very famous kind of quadratic equation word problem. A ball is thrown upward from the top of a 40-foot high building. There's just people throwing things off buildings all the time in these math classes. At a speed of 80 feet per second, and the ball's height above the ground can be modeled by this quadratic equation. When does the ball reach the maximum height? What is the maximum height, and when does it hit the ground? Okay, so before we look at any numbers, let's just think about what's going on here. We've got a quadratic equation. The leading coefficient is negative, so it's going to open down, right? It's going to look something like that. So when does the ball reach the maximum height? So let's just think this is the height and this is time, right? This is h as a function of t. That's the equation that they gave us. So when does it meet the maximum height? Well, that's going to be the t value of the vertex. What is the maximum height of the ball? That's going to be the y value of the vertex. We're getting good at finding these vertexes. And when does the ball hit the ground? Well, that's when the height's going to be 0. So that's going to be the y, an x-intercept. Haven't found that yet, so that'll be good. All right, so when does the ball reach the maximum height? Well, the t value of the vertex is going to happen at minus b, so minus 80 over 2 times a, right? A, B, C. So that's going to be minus 80 over minus 32. And again, I cheated. We could put this in our calculator, but that's going to be at 2.5. Does that make sense? What are the units? That's 2.5 seconds is when the ball will be at its maximum height. Yeah, that seems kind of reasonable. All right, how about what is the maximum height? Well, we just find h of 2.5. We plug it in, we get minus 16, 2.5 squared, plus 80 times 2.5, plus 40. And again, I cheated. Put this in your calculator, work things out. You get 140 feet. Okay? When does it hit the ground? Okay, so this is going to be a little bit different. We have to figure out what the x-intercepts are. So let's look at this equation. The numbers look kind of big. We're probably going to have to use the quadratic equation. I'm not sure I can factor that very easily. Quadratic equation always works. So let's use the quadratic equation. T is going to equal minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, I have confidence that you guys can solve this equation. You just put things in your calculator and are careful about signs. I'm not going to work it out each of the steps, mostly because it's calculator work. And the numbers that we get are going to be 5.458 and minus 0.458. So does that make sense? If the highest it got was at 2.5 seconds, will it hit the ground at 5.458? Yeah, I believe it, right? That's about halfway. What is this minus 4.58? Well, remember we were here when we threw the ball. We were on a 40-foot high building throwing a ball off of the building. I don't know why. That's kind of like in the past. If we had thrown it from the ground, that's when we would have thrown it to sort of replicate the same arc of the ball, right? But we kind of started mid parabolic motion of the ball and threw it from right here, right? So that minus 4.58 is like here at negative time. Didn't really happen, but that would be like if we had thrown it from the ground, when we would have had to throw it to have the same arc. Okay, so those are the main kinds of word problems that you're going to be solving with quadratic equations, right? You're going to be maximizing things, meaning finding the vertex, and you're going to be finding y-intercepts or x-intercepts, just like we do normally. If we're interested about parabolas, those are the kinds of things that we talk about as being properties of a quadratic function, right? So those are some applications. Hope that made sense.